In this video, I will explain what is an inverse of a function and show you how to find the derivative of an inverse function. Say suppose sine inverse of x. Firstly, what is an inverse of a function? Let's take the example function y equals sine x. Here, x is the input value and y is the output value. So for say x equals pi by 6, sine x, that is y, will equal 1 by 2, and for x equals pi by 2, sine x, that is y, will equal 1. Now the inverse of this function will be x equals sine inverse of y. Here y is the input value and x is the output value. Sine inverse of y will be that value of angle theta such that sine theta will be equal to y. So sine inverse of half would be pi by 6. And sine inverse of 1 will be pi by 2. Note here we are taking only the principal values of x. Now you would have noticed that an inverse of a function, for an inverse of a function, we are only interchanging y and x. So for y equals sine x, for input pi by 2 we get output 1, and for the inverse function we'll get, which we will denote with y equals sine inverse of x, for input 1 we will get output pi by 2. So I have already drawn the graph of y equals sine x. Now to get the graph of y equals sine inverse of x, we only replace x-axis with y-axis and y-axis with x-axis, and the curve remains exactly the same as in y equals sine x. Therefore, this will be the graph of y equals sine inverse of x. So this is the graph of y equals sine inverse of x. Here you can rotate the graph to get the x-axis on the horizontal line, but I will keep the graph this way for now. Now let's talk about the derivative of these two functions. First I'll draw the graph and then explain the content. let this be the graph of y equals sine x. Now, I have chosen any arbitrary point A on the x-axis, and corresponding to that value, we get a point B on the y-axis. To calculate slope at point A, we move little forward on the x-axis and observe the change. We move little forward from the curve on the x-axis and observe the change in the value of y. Thus, the change in value of y upon the change in value of x, which I am denoting by delta y upon delta x, would be the approximate slope at A. If we decrease delta x to an extremely small amount, then delta y by delta x would be the exact slope of the curve at point A, which we also call the derivative of the curve at point A. Now we know that the derivative of sine x is cos x. So here delta y upon delta x will approach cos A as delta x approaches 0. Now, to get in the context of y equals sine inverse x, we will interchange y with x and on the same graph, so we get the graph of y equals sine inverse of x. Here, the change in the value of x old will represent the change in the value of y new. And similarly, the change in the value of y old will represent the change in the value of x new on the new graph. So the slope at point A on the new graph would be delta y new upon delta x new, which is equal to delta x old upon delta y old, which is the reciprocal of the derivative of the old graph. So which will equal to which will be equal to 1 upon cos of A. But since we measure the slope with respect to the x-axis and not the y-axis, the slope of sine inverse of x at point x equals b would be 1 upon cos of A, which we can also write as 1 upon cos of sine inverse of B, because we want to express the slope in terms of the value on the x-axis. This can be further written as 1 upon root of 1 minus sine square of sine inverse of B, which will be equal to 1 upon root of 1 minus B square. Thus the slope at point B on the graph y equals sine inverse of x would be 1 upon root of 1 minus B square. In this way, you can find the slope of the inverse of any graph if you know the slope of. In this way, you can find the derivative of the inverse of any graph if you know the derivative of the original graph. Thank you.